Have you ever wondered how scientists discover the genes that increase your risk for diseases like hypertension, coronary artery disease, or diabetes? Meet GWAS and PheWAS, two powerful tools unlocking the genetics of complex diseases. GWAS, or Genome-Wide Association Study, starts with a disease, like coronary artery disease, and scans the entire genome across thousands of individuals to find genetic variants. Usually SNPs that are more common in people with the disease than in those without. For example, GWAS has identified SNPs near the 9p21 locus as strongly associated with CIAD. Similarly, variants in the FTO gene are commonly linked to type 2 diabetes. These studies test millions of variants one by one to see which are statistically associated with the disease of interest. Now flip the script. Instead of starting with a disease, PheWAS, or Genome-Wide Association Study, starts with a genetic variant, and looks across hundreds of clinical outcomes or phenotypes to see what that variant influences. PheWAS uses large clinical databases like electronic health records linked to genetic data, making it ideal for real-world analysis. Imagine we pick a SNP in the SH2B3 gene. A PheWAS might find this SNP is associated not just with hypertension but also with atrial fibrillation, stroke, and autoimmune diseases like celiac disease. Pleiotropy happens when a single gene influences multiple traits. PheWAS is perfect for detecting this. In metabolic syndrome, for instance, a SNP in the TCF7L2 gene might be linked not only to diabetes but also to lipid levels and blood pressure, highlighting a shared genetic root. This multi-trait insight is key in understanding the biological mechanisms that link these conditions. By identifying pleiotropic genes through PheWAS, we can develop polygenic risk scores that predict multiple disease risks simultaneously, target shared pathways with multi-purpose drugs, for example, using anti-inflammatory drugs for both heart disease and diabetes, and advance precision medicine by tailoring screening and prevention based on an individual's genetic pleiotropy profile. For instance, if a person carries a risk allele in GCKR, which affects glucose, lipids, and uric acid levels, clinicians might monitor for diabetes, dyslipidemia, and gout, all from one genetic clue. GWAS tells us which genes are linked to a disease. PheWAS asks, what diseases are linked to this gene? Together they create a 360-degree view of the genetic architecture of complex diseases. As we integrate genomics with clinical data, PheWAS will play a growing role in identifying genetic pleiotropy, the key to unraveling disease networks and advancing precision medicine. Subscribe for more on how science and technology are transforming healthcare, one gene at a time.